So that is the area under this curve is equal to 1. And you have got to show this expression k, the integral between pi and 0 of 0.2 plus sine t minus 0.2 cos squared t minus sine t cos squared t dt is equal to 1. Now you can see obviously it's going to be equal to 1 because the area is equal to 1. So this equal to 1 should be giving you a big clue that you're working out the area under this curve between the x values or the t values, because we're going to be working parametrically, and you've got to show this expression, and that will give you 3 marks in the exam. For part B, we have to determine the exact value of k. So basically we've got to solve this equation you've got here, or this expression, and that will give you 6 marks in the exam. So you've got to set it up to start with for 3 marks, and then you've got to solve it and get the answer for 6 marks. Now the key facts you're going to need to be able to do this. First of all, you need to know what the word show means. So that means you need to work out how to find this expression, okay, and work out how to get the answer. So you've got to use the fact that the area is 1. So that means you know you're integrating between your x value, obviously 0 here. You've got to work out the value here. And then you've got to work out the limits, okay. So you'll find that this value here is pi. And 0 is down here because you can see that in this expression here. And when you integrate the area of this curve, will give you this expression here. So that's what you've got to do for part A. Part B, it says determine. So that basically means work out what is the answer. So you've got to solve this to work out the value of k. Remember the area under the graph you are integrating. You're going to have to change the limits to be in terms of t on this question because this expression here is all in terms of t. So these values here are t values. You can see up here we were given some t values. That will help you. When we're integrating parametrically, we need to know that we're integrating my function y. Now normally we integrate y with respect to x. But you can see here I've got dx by dt times by dt. Now if you imagined you crossed out these dt's here, you're left with the integral of y with respect to x, which is how we normally integrate. But to integrate parametrically, we need to add in these extra dt's to be able to solve for the question that we've got here. So this is a really important question when we are, or a formula when we're integrating parametrically. So make sure you're aware of this formula. You write it down and you highlight it if you're unaware of it. You need to know how to differentiate cos t. So the differential of cos t is minus sine t. You need to know that sine squared t is the same as 1 minus cos squared t. So that's an identity. You need to know that if you integrate sine x with respect to x, you get minus cos x plus c. And you need to know if you integrate cos x with respect to x, you get sine x plus c. You also need to know that cos squared of x is the same as a half 1 plus cos 2x using your double angle formulae. So this is a really important formula that you need to know. And if you know it off the top of your head, you'll be quicker at using it in the exam. In most exam papers, they will either ask you to differentiate or integrate sine squared or cos squared of x. So you must know these expressions here to make it much easier for you in the exam. And in the formula book, you have got this expression here, that you've got f dashed of x, f of x to the power of n dx is equal to 1 over n plus 1, f of x to the n plus 1 plus c, remember when you integrate. Now this formula here is given to you in the formula book, so make sure you know that formula or where to find it, but a lot of people forget to use it. And if you look here at the end, okay, I've got a bracket, a squared term here, cos squared t. So my f of x is going to be cos t all squared, and the differential of cos, okay, we can see up here the differential of cos is minus sine. Look, there's a minus sign at the front, so that's going to give you a real clue for integrating this last part here. So this is a really important formula, make sure you know it. So these are the formulas that you're going to need throughout this question to give you 9 marks for this question. Press pause, have a go at working out the answer, and then press play when you're ready to hear the answer. Now for part A, the key facts you're going to need are written down here on the left-hand side. So these are the bits we're going to need to be able to show that this expression here is equal to 1. So to start with, we're going to look at the limits. We're going to change these limits to be in terms of t. Now you can actually see it says it's between 0 and pi, but we're just going to clarify why it is between 0 and pi. So our limits are when the y equals 0, because we're finding the limits between this point here on the graph and the other point here where we cross the x-axis. So when we're crossing the x-axis, y is equal to 0. So that means this expression here, y equals k sine squared of t is equal to 0. So from here I can divide by k and I can square root, which means that sine t will equal 0. To find the value of t, I need to turn my calculators into radians and do sine to the minus 1 of 0, which will give you an answer of 0 or pi. So these are the limits between pi and 0 that you can see here in the show that question. They've also been given here. Now the first part of this, we have got to use the formula here, y dx by dt dt. So I'm going to work out the value of dx by dt. So we're told that x is equal to 1 plus 0.2t minus cos t. So differentiating this function here, the differential of 1 just disappears. The differential of 0.2t becomes 0.2. The differential of minus cos t becomes plus sine t. And this will give you 1 mark for differentiating x with respect to t. From here, I'm going to put this dx by dt, the y, my limits, and the dt into this expression here for integrating parametrically. My limits are between pi and 0. I've got my expression here for y, which is k sine squared t, times by 0.2 plus sine t, which is dx by dt. All lots in terms of t, dt is going to equal 1. Now this expression here, sine squared t, can be written as 1 minus cos squared, and my k is a constant, and that can come to the front of the integral. You can see in the answer here there is a k out the front, so I can just bring that out nice and early. Sine squared t is the same as 1 minus cos squared. This part here has stayed exactly the same. So you get your second mark for getting to here. The last mark comes from expanding the brackets. So we're multiplying two brackets. So I need to do 1 times by 0.2, which is 0.2. 1 times by sine t, which is just sine t. Minus cos squared t times by 0.2 is minus 0.2 cos squared t. And minus cos squared t times by plus sine t is going to give me the minus sine t cos squared t. And you can see from here, this is my third mark. You just need to identify that you've shown what you're trying to work out. So if you look at the question here, this is exactly the same. 0.2 plus sine t minus 0.2 cos squared t minus sine t cos squared t, all with respect to t, and that will equal 1. Remembering your limits are between pi and 0, and your constant k is at the front. Give yourself a big tick if you got the first section correct. Well done. On the second part, we have got to determine the value of k. Now for this question, it's worth 6 marks, and you're going to need to know these steps over here. So this will help us for the second part. So this is where we're starting with k between pi and 0 of 0.2 plus sine t minus 0.2 cos squared t minus sine t cos squared t dt is equal to 1. As I said earlier on in the video, this part here, sine minus sine t times by cos squared t, is using the formula that's in the formula book, where f of x is equal to cos t, f dashed of x is the differential of cos t is minus sine t, so this is minus sine t times by cos squared t. So we're using this part here that's in the formula book. Now cos squared t, we can use the double angle formula to help us integrate. So cos squared of x is the same as half 1 plus cos 2x. So I can write cos squared of t to be a half of 1 plus cos 2t. So I'm just going to replace this section here with the half 1 plus cos 2t. I can then multiply 0.2 times by a half, and half of 0.2 is 0.1. So I've got minus 0.1 times 1 is minus 0.1. And then I'm going to have a minus 0.1 times cos 2t, which will be minus 0.1 cos 2t. Here I've got a 0.2 minus a 0.1, which can combine together to give me 0.1. The sine t is still here. I've got minus 0.1 cos 2t minus the sine t times by cos t all squared with respect to t, and that equals 1 still. Remembering the k outside the front of your integral sign. Now 0.1 is easy to integrate, so that becomes 0.1t. We've got here the integral of sine x is equal to minus cos x, so that's nice and easy to integrate. The integral of minus 0.1 cos 2t, so we know cos x is integral to sine x. Remember, when you've got a value in front of the t, you have to divide by the differential of what's after this. So the differential of 2t is 2, so you're going to have to divide by 2. And this last part here, we're using the rule in the formula book. So for getting 0.1t minus cos t, that will give you 1 mark. For getting it in the correct form with these last 3 terms here, you will get 1 mark. So the integral of 0.1 cos 2t is minus 0.1 divided by 2. Remember, the differential of 2t was 2. Differential of cos was sine, so that stays as sine 2t. And then I've got cos t all cubed divided by 3. Okay, so remember, I've got a minus sine t here. The differential of cos, okay, is minus sine, which is why there's an extra minus in here. So we've got minus a third cos t all cubed, and that is between pi and 0, and the whole expression is equal to 1, remembering your k at the front. From here, I could just tidy these 2 minuses to make a plus. 0.1 divided by 2 is 0.05, and I can put in the values of pi and 0. So by tidying this up a little bit, I've got the plus in here, I've put my pi's in at the front, and I've put my zeros in. Now just beware, when you put 0 in, not all the terms become 0, okay, because sine and cos of 0 are not necessarily 0, so you need to check on your calculator or just know the values of sine and cos of 0. So 0.1 pi just stays as 0.1 pi, remembering the k at the front. Cos of pi is the same as minus 1, so just type that in your calculator to find that's minus 1. So you've got 2 minuses there, that's going to become a positive. Sine of 2 pi is just 0. Cos of pi is minus 1 again, so I've got minus 1 all cubed times by a third. Then I'm going to have 0.1 times 0, which will just be 0. Cos of 0 is minus 1. Well, cos of 0 is 1, and then the minus at the front makes it minus 1. Sine of 0 is just 0, so this term is 0. Cos of 0 is 1 again. 1 cubed is just 1 divided by 3, so it's a third here on the end. So that will leave me with k lots of 0.1 pi. I've got a 1 here from the front here, minus a third. I've got a minus times the minus gives me a plus 1, and then the minus times the plus gives me the minus a third. So 1 plus 1 is 2, minus a third is minus 2/3, and that will equal 1. So we get 1 mark for getting to here by putting in your values for pi and 0 and working each term out separately. I would recommend you work out each term separately, because otherwise you can get confused and your calculator won't give you the answer in exact form. So you need to work out each term separately to be able to work through to the answer, because the questions are, say, in exact form. Next, we just combine those values to give me the 2 minus the 2/3 of pi. We now need to get k on its own. So we're going to do 2 whole ones take away 2/3. So that's the same as 6 over 3 take away 2/3. So 6 take away 2 is 4. So I've got 4/3. So I'm going to divide by the 0.1 pi plus 4/3. From here, I'm going to get rid of this divide by 3, so I'm going to multiply everything by 3. That will leave me a 3 in the numerator, and 0.1 times 3 gives me 0.3 lots of pi. And then just plus 4. From here, I'm then going to multiply everything by 10 to just get rid of the decimal here in front of the pi. So I've got 30 over 3 pi plus 40. And this is for your 6th and final mark. Give yourself a big tick if you got that correct. Great work. Well done. The mark scheme of this question shows that The method marks are here, so B1 and M1 are method marks. Dep means dependent on your previous answer, so if you made a mistake here, you can still get the method mark. AG means that it is show that question, so you must have enough reason to why you get the answer mark here to get the full 3 marks in the exam. The mark scheme for part B again shows the method marks here totaling 6. So B1 are method marks, M1 is a method mark, A1 is an answer mark. You cannot get a method mark or an answer mark until you've got method marks. The stars here, if you look on the right hand side for the guidance, it means it could be anything of the correct form. So as long as your answer is looking like the forms that have been provided over here, or given the correct information that it says over here, you can still get a method mark for that step of it. And it is dependent on the answer you got in case you made a mistake somewhere. To get the full marks, it has to be the correct answer. OE means or equivalent. So if you wrote it in a different form as 1 over 0.1 pi plus 4/3, that is absolutely fine. So you will still get the full 6 marks for leaving your answer in that form. If you found this video useful, please share, like and subscribe so we can all get great at maths.